Alright, hard to believe, February 22nd, this should be our last last new topic of the school year, so let's just get to it. The area bounded by the polar curve r equals a function of theta between alpha and beta is given by this formula. So the area is 1/2 the integral from alpha to beta of r squared d theta. Okay, so before we apply that to this function, let's get a little bit of an idea what this looks like. So if we plug in, and we could do a little t-chart here if we want to, theta and r, and if we go 0, so theta, sine of 0 is 0, so that would be 2. So that would be right here. Now I didn't put all the circles on here because I don't clear in the lines for the angles, but so it looks more like the coordinate plane than a polar plane. But anyway, so if we go up to pi over 2, the sine of pi over 2 is 1. So it's going to be 1 times 2 is 2, 2 plus 2 is 4. So that's going to put us up here. And then if we, that's 4. Then if we plug in pi, 180 over this way, that's going to be, hold on a second, that's going to be 0. Sine of pi is 0, so that's 0, so that's going to be 2 again. But remember, that's going to be 180 and 2, so it's going to be over here. And then let's look at 3 pi over 2. So 3 pi over 2, that's going to be -1, so that's going to be -1 times 2 is -2. 2 plus -2 is 0, so that's going to be back here. And then if we go to 2 pi, that would be 0, so that would be 2 again. So we're starting here. I don't know if I can draw this very well, but I'm not sure how far it comes down this way, but so it's something like that. I don't know if I do that very well. Polar, a little bit tricky. Okay, so we're trying to find, so kind of the reason I did that was to show that we needed to go, so we started here and we went all the way around back to here. So if we use the formula then, 1/2, and we went from 0 to 2 pi, and that brought us all the way back to seal the area bounded by that graph into that here, inside here. So that's what we're trying to find the area of. And then we're going to, so it's just really just memorizing the formula and then also kind of figuring out what angles that you're going to need as far as whatever you're asked to find. Okay, so that's going to be 4 plus, if we multiply this together and double it, that's going to be 8 sine theta, and this will be 4 sine squared theta. Okay. So I'm going to actually, because these are all even, I'm going to go ahead and distribute that 1/2 and just multiply it through there and make those numbers smaller. So now actually on the sine squared, if we go back and think about some of those formulas, sine squared is equal to 1 minus cosine 2 theta over 2. Using one of the identities. So if we want to make that substitution because it'll be easier to integrate. Okay, so those are going to cancel out. Notice how I'm not putting equal signs in between there because I'm just simplifying this stuff. And so let's go back to the whole thing now. So I distributed that in. This is 0 to 2 pi. Here's a 1, so 2 plus 1 is 3. And then we have 4 sine theta minus cosine 2 theta. Alright, so now we're going to integrate this. So this is going to be, so we have d theta, so we're going to integrate, so we put like if this was a dx, we would integrate this and we would get 3x. But it's theta, so we're going to have theta here. Now if we integrate for sine, that's going to be cosine. But normally when we take the derivative of cosine, we get a negative, so this must be negative, because the derivative of cosine is negative sine, and negative negative would be positive. Now, here, we could do a little u sub over here and get u equals 2 theta and du equals 2 d theta. And we don't have a 2 there, so that would be 2 1/2, just kidding. 1/2 du equals d theta. So that's going to be 1/2 and then sine 2 theta, like that. Okay, so 0 and 2 pi. Like that. So if we plug this in, we're going to have 3 times 2 pi minus 4 cosine 2 pi minus 1/2 sine 4 pi minus, if we plug 0 in here, we get 0. If we plug 0 in here, the cosine of 0 is 1, so that's going to be negative 4. I probably could have done that here too and just done, and then sine of 0 is 0, so that's going to be minus 0. So I probably should have done it here. This is just 6 pi minus 4 and minus 0. So actually this is going to be plus 4. That's going to cancel that out. So our final answer is just going to be 6 pi. Alright. Now, if we look at this next one, it says find the area of one petal of this. Okay, so if we look at that, if we do 2 sine of 3 theta equals 0, divide by 2, so you can get sine of 3 theta equals 0. And if you think about it, if we take the inverse sine of both sides, we'll get 3 theta, and then the inverse sine of 0, so that what they're asking is the sine of what angles give us 0. Well, 0 and pi and 2 pi. Okay, so if we divide both sides by 3, we're looking at 0 pi over 3 and 2 pi over 3. Okay, so we're going to start at 0, and I'm not going to be able to graph this very well, but basically we're going to get a petal over here, and I might not be graphing this in the right order either, but something like that. Okay, and we're trying to find the area of one petal. So we're starting at 0, and then by the time we get to pi over 3, we hit 0 again, and then down, and then, okay, and we could get more values as well, but since we're just trying to find one petal, so that's still, the formula is always 1/2 there, and we're going to go from 0, and by the time we hit pi over 3, we're going to be back to 0, so that's going to be one petal. So that's kind of how I'm determining these values here. And then we just take the function and square it. Alright. And should we do this on the calculator? If we do it on the calculator, it turns out, although on the calculator you might have to switch it. I wonder if you could just do it just like that. Probably could. Just use x's instead of thetas. Or you could use thetas as well, maybe. That turns out to be 1.047, which is actually pi over 3. Okay. So as we practice for the AP exam, we'll find out if they how much they ask us to do by hand and how much they ask us to do on our calculators. Okay, so if we do that same kind of thing here and we set 4 cosine 2 theta equals 0, and so cosine 2 theta equals 0, so cosine equals 0 at pi over 2, and 3 pi over 2, and 5 pi over 2. Okay, so if we multiply both sides by 1/2, we're going to get pi over 4 and 3 pi over 4. But we're just doing one pedal. Just like up here, we're doing 1. So I'm looking for those first first two values where we're going to. So if we plug in 0 for theta, then we would get 4. So at 0, we're at 4 over here. And then at pi over 4, we're going to get cosine of pi over 2, which is 0. So that would bring us back to here. Okay. Then, if we go from 3 pi over 4 and multiply by 2, that'd be 3 pi over 2. That's going to be 0 again. So we might want to plot some more things in there. So it seems like this is going to go like this, and then this, and then this, and then this, and then that. Something like that. I probably didn't do that very well, but alright, so what this is doing, kind of the same thing we did there, is it's giving us a place to go from 0 to 0, so it's giving us one leaf of this, one petal of this. So if we started, if we did a little t-chart, like we did up here, and we did 0, then we would have had 4, and then if we go to pi over 2, would be oh wait, pi over 4 is what we did next, sorry. So pi over 4, that's pi over 2, that's 0. Then if we do pi over 2, that's going to be pi, that's going to be -1, so that would be -4. And then 3 pi over 4 would take us back to 0. So that's this pedal right here. Okay? So we could do that. Maybe that would be the safest thing to do, to just follow that pattern. So we'll go 1/2 from pi over 4. And I have another idea, but I'll tell you about that in a minute. Okay? And then we have 4 cosine 2 theta squared d theta. Okay? So if we, what do we want to do here? We can square this, and we would get 16 cosine squared 2 theta. Okay. Now, let's see what we want to do here. If we switch cosine squared, we would have 1 plus cosine, and then we double the angle. So that's going to be 4 theta over 2. Okay. Now, the 16 we can, I want to leave 2 inside here, so I'm going to change this to 8 times 2. So I'm going to leave a 2 there. This is 8 times 2. I'm going to take that 8 out. That's going to be 8 times 1/2 is 4. So I'm just kind of rearranging those, the factors of that. 3 pi over 4. Okay. And so that's going to cancel that out. So now we have this. Okay, so if we integrate that, we're going to have 4, and if we integrate that, it's going to be theta. And we could use a u substitution on here, but maybe we can see that pattern from up on example 1, that's just going to give us a 1/4 sine 4 theta. Okay. And you can check that real quick. Take the derivative of this. The derivative of sine is cosine, and we'd have to use a chain rule, multiply by 4, which would cancel that out, and then we would just be here. But you could use the u substitution if you need to. So you could say u is going to be 4 theta, du is going to be 4 d theta, and so 1/4 du. So that'll give us a 1/4 out there. So now if we substitute that in, it's going to be 3 pi over 4 plus 3 pi over 4 times 4, that's going to be 3 pi. The sine of 3 pi is 0, so that's going to be 0, minus pi over 4, and then this would be distributed. I could put parentheses here, I could just distribute it, minus, and if I plug pi over 4 in here, I get sine of pi, which is 0 also. So instead of putting parentheses around that, I went ahead and distributed the negative, but this is 0 anyway, so that's not a big deal. So here, if we subtract these, I'm going to get 2 pi over 4 times 4, so the 4's will cancel, and that's just going to be 2 pi. Alright, now, the other idea I had here was, if we think about symmetry, okay, we could have integrated this from 0 to pi over 4 instead. Okay. Now I don't want to go back and do that to see how much less work that is, but I mean, it really wasn't that big of a deal to plug in pi over 4 here, so not sure if this will be much less work, but we could do it that way. Alright. So let's go on and look at, now it says polar equations in area day 2, but I'm just going to go ahead and do it right now at the same time. So all 3 of these examples are actually, if you look at the equations, the same equations. So we're going to go ahead and graph it, and then we'll put it on all 3 of these. So let's see what we have here. Alright, so I started doing a t-chart for this one also. So if we plug in 0 for sine, we get 0 here, plus 1, so that's 1. So the angle is 0 and the distance is 1. Remember, this is a polar graph. There should be circles on here, but and lines for the angles, but I didn't want all that. So pi over 2, sine of pi over 2 is 1. 1 times 2 is 2. 2 plus 1 is 3, so that's going to be up here. Okay. And then if we plug in pi, sine of pi is 0, so that's 1. So that's going to be a pi. That's going to be 1 over here. Okay. Alright, so I do want to check 3 pi over 2, but before we do that, one of the things we did on the other examples was we set these things equal to 0, so we could find out the value, the angles that would give us 0. So if we do that here and subtract 1 from both sides and then divide by 2, we're looking at when is the sine equal to negative 1/2. So if you think about the unit circle, negative 1/2 for y would be the small number, and the same thing over here, negative 1/2. So that's going to be pi over 6 past pi. So that's going to be 7 pi over 6, and this is going to be pi over 6 less than 2 pi, which is 11 pi over 6. So in between, somewhere in between pi and 3 pi over 2, we're going to hit 7 pi over 2, which is 0, which is right here. And then if we plug in 3 pi over 2, 3 pi over 2 is negative 1, sine of 3 pi over 2 is negative 1. So this is going to be negative 2 plus 1, which is negative 1. So when we go down here to 3 pi over 2, remember negative means go in the opposite direction. So that's actually going to bring us up here. And then when we hit 11 pi over 2, that's going to bring us back down to 0. And then we get back to 2 pi, that's going to bring us back over here to 1. So, not sure exactly how that looks. Probably that's a little bit, and then it's going to come, I don't know how far down that goes. It's going to go up like that. And, alright, so something like that. So here, the question is asking for what's the inner loop of the graph. So it's asking for that little part here. So we hit 0 here at 7 pi over 6, and then we're back to 0 at 11 pi over 6. So those are the two angles that we want. So we're going to have 1/2, which is just the formula, and then 7 pi over 6 to 11 pi over 6 is just going to give us this little loop right here. And then we will square this, because it's in the formula to square r. Alright, and if you do that, it comes out to be 0.544. Remember, we need to go to 3 decimal places to the thousandths place. Okay, so we already have those values, so I don't know, I'll try this again. It seems kind of narrow, and 0. Alright, so I don't know how wide this thing gets. Up like that, and like that, and then here, and a loop, and around. So it has symmetry. Okay, so now it says find the area of the graph. So now it's asking us for the area of the whole thing. So if we do this, and we find the area of this, and it hits there, and here, so it's a little bit tricky. So if you think about it, if we do the 1/2 and we go from 0 to 2 pi, that would be all the way around. You can experiment with your calculators about entering this in and see what it says. That would be the area of all of this. But as it goes around and hits here and here, it's going to give us the area of all that. And then we're also getting the area of this a second time. So this is actually being counted twice. So when we go all the way around here, we're getting the area of all of that. And then when we go around here, we're getting the area of that again. So it's being counted twice. So we need to subtract out the area, which is actually the area we got up there, 0.544. We're going to need to subtract that. Okay. And we might want to point out the loop was counted twice. So that's why we're subtracting it out. Okay, so when you do that, that turns out to be, and you follow the same procedure we did on the first couple examples. Square that out, switch the squared to 1 minus or 1 plus cosine over 2 theta over 2. Okay, and this last one down here, again, same. Okay, so something like that. Now it's just asking us for the area between those loops. Okay, so here it's almost the same thing as that if you think about it. So we'll start off with this. This will be 0 to 2 pi, and we can just put r squared here like that. And then, well, maybe we should write it out the other way. Now here, remember, it's 1/2, but this loop is actually being counted twice. So if we just want this area, we're going to have to subtract out, maybe I should have put that 2 times 1/2 to emphasize that here. Okay. So 2 times 1/2. The loop was 7 pi over 6 to 11 pi over 6. Okay, and there we can just actually subtract those two numbers, so that's going to be 8.338. Okay, now actually there are 2 more examples, but I'm going to wrap it up here. That's been a bit of a stretch. We'll see if those two, as we do practice exams, if those 2 examples come into play, we'll go back and do them. Or you can look them up if you want to, try them out. Alright, you have successfully completed the notes part of Calculus BC, AP Calculus BC, and we will be moving on to review after you do these assignments. So congratulations, way to stick with it. I know it's been a strange year with COVID and distance learning, but hopefully we'll get to see each other a little bit in the 4th quarter to do some practice AP tests. Alright, bye-bye.